Hi all, welcome to module 14. In this module, we'll look at understanding the basic concepts that affect security for a web app and looking at some common best practices. This module is unfortunately going to be listing down quite a few point after point, so it might get a little boring, so bear with me. Let's look at the common loopholes that cause security breaches. The first most common loophole is edge cases that are missed out by the developer, or in case the web app is being used by users or hackers in a way that breaks the developer's assumption. The most common example of this is when the developer forgets to add an authentication or an authorization check to an API endpoint. So that means that let's say you're taking an API endpoint that places an order and you forget to check if the user ID is logged in. A high profile example of this case was when Ola app was hacked by a developer and the developer was able to place recharges of an arbitrary amount of money. The second kind of example is when hackers are able to execute code where developers don't expect code to be executed. A very common example of this used to be when amateur developers would set up a PHP service and would allow file uploads to happen. So users would upload a file, but instead of say uploading an image, which is what the developer was expecting, user or the hacker uploads a PHP file. Now, if we visit this PHP file by trying to go to say the images folder and fetch this file.php, if the web server or the directory is not configured correctly, the PHP file will actually end up getting executed. So this means that a random user who is not a developer is able to execute code on our server machine. So the user or the hacker can potentially get access to all the different files that are there on the file system, can even start making requests to the database, can try to find out what the database username and password is, and such things become possible. So another common loophole is when people who are not authorized enough are able to access data. So a common example of this is when we have an application and we have a testing environment and a production environment. So a testing environment is when we have an application that is deployed on a test server, and a production environment is when it's finally deployed on the actual server. That is the app that our users use. So the domain points to the production server, and when we test the application, we test it on the test server. So a common error that happens in this case is that a developer or a tester who is testing things is mistakenly given credentials to access the production database. Now, the tester might not know this. Now, the tester himself or herself might not be malicious, but if the tester does not store credentials carefully, then another user or a hacker can get access to these credentials and they will be able to access the production database. The fourth kind of loophole, which is often outside the control of developers or the organization, is a denial of service attack. So denial of service attack is a kind of an attack by hackers that aims to make either a part of a network or the server software unavailable to our users. And a typical way of doing this is that hackers would make so many requests to our site that normal users will not be able to reach the site because the site is overloaded. The last kind of example, which is getting increasingly popular today, is social engineering. So for example, we take all the best practices to secure our systems, but we're not careful about where we stored our credentials or passwords or keys. So these kinds of things are not really a technical problem, but are just a problem with the way we manage or organize policies in our team. So to understand what the sources of these different security vulnerabilities are, let's look at the architecture of a web app. We'll start from the right. The browser is making a request through the network to the computer, which is the server host, and then to the web server software. So the first place where things can go wrong is the browser itself. The vulnerability might be in the web app source code, the code that we have written, or might be in the browser itself. On the network, it could be because hackers have access to the data that is in transit between a browser and a computer, and they're able to access that. It could be because there's a denial of service attack on the network components, which is not allowing our users to access the server itself. It could also be because of man-in-the-middle attacks where the network has been completely compromised and there is a hacker or another agent that is sitting in the middle that is pretending to be a web server and is not really a web server. On the computer or on the server side of things, there might be vulnerabilities in the web app source code, or there might be vulnerabilities in the operating system or the library that is being used. These are the three main touch points from where the main security vulnerabilities can come from. And our objective is to try to understand what are the common things that go wrong and how we can prevent those common things from going wrong when we think about security. So first, let's talk about the front-end code and let's make some fundamental concepts clear so that we understand where security vulnerabilities can come from. The first thing to understand is that on the browser, users and hence hackers have full access to our front-end code, right? The HTML, the CSS, and the JavaScript is completely accessible to any user who comes to our site. This means that we cannot store any secret data or credentials or access tokens that are secret to our application in that source code. The second thing to understand is that we are dependent on the browser to provide security to our web app. So our application, our entire application is only as safe as the browser is from the front end point of view. Just to give an example of this, when you use Chrome browser extensions, some browser extensions can ask the user for permissions to read and modify data on the web app itself. That means that if hypothetically there is a malicious extension or a bad Chrome extension on the Chrome App Store, then and we install this Chrome extension, then this Chrome extension can extract our session IDs from our web apps cookies, or can send them to some agent, and that agent can start using our session IDs for making requests on our behalf. Third thing that is important to remember is that if we include JavaScript libraries from third-party locations, then those pieces of JavaScript code have full access to do anything on the web app, right? Because we as developers specified that those JavaScript files should be used. That means that those JavaScript files have full access to do anything that they want on the web app. For example, if we are including, say, the jQuery JavaScript library, and we loaded the jQuery JavaScript file from an untrusted source. So the untrusted source might have modified the jQuery library to have malicious pieces of code that are extracting user data. The fourth important thing to remember is that if in our HTML for any reason a script tag is added, either added by modifying the HTML or added when the HTML was first loaded, that code inside that script tag will be executed. So that means, for example, let's say we have a comments page and users are allowed to type comments on each other's articles. So let's say I go to a comment box and I type a JavaScript piece of code which is script alert hello, and I close the script tag. That means that if anybody else loads this product page and they load the comment that I have typed in, this script tag will execute and a hello will show up in the alert box. Now imagine if I'm a evil person and I don't write alert hello, but I write JavaScript that the user can't see, right? And the JavaScript just starts executing. So it's important to validate the user input while users are sending that data or while displaying data that users have written. So that means the only way to sort of prevent this error is to ensure that if your web page is displaying content that another user has written, it must be displayed in a way that the script tag is not included as if it's HTML into the HTML document. A very simple thing that a lot of developers forget to do, which become a source of common errors and security risks, is if we don't update libraries that we use frequently. For example, if we're using jQuery, we should make sure that we're on the latest stable version of jQuery. And we should always also make sure that we keep asking our users to upgrade and stay on the latest browsers that don't have security vulnerabilities. Let's come to network security. The first thing about network security is to understand that the network is not really owned by us. So if we're the developers, we don't own anything on the network. So anything really can happen on the network, and we must be ready for that to happen. The most common example of network security breaches are called man-in-the-middle attacks. Click on that link and find out how man-in-the-middle attacks work and what kind of security breaches they can cause. The only way to protect ourselves, despite the fact that the network is not owned by us, is to ensure that there is end-to-end encryption between the client and the server. HTTPS is secured HTTP, which means that HTTPS is basically HTTP but with end-to-end encryption, so that the network in the middle, if compromised or if somebody is trying to read our traffic in the middle, they can't read that data because the data is encrypted. The browser creates an HTTPS connection and is able to encrypt data to send to the server by using SSL certificates that have been installed on the server. However, the interesting thing about end-to-end encryption is that while we can somehow ensure that the data that is sent from our client to the server is encrypted, how can we ensure that the server is actually the server? For example, when we connect to google.com, how do we even know whether the server is actually google.com? And this is where the second more important property of SSL certificates come in, where SSL certificates are actually used to identify that a domain belongs to the server that is responding to a request. And the way this works is that whenever a browser makes an HTTPS connection, the browser cross-verifies the SSL certificate that is sent to it by the server with a certificate authority. And the certificate authorities are inbuilt into the browser, and we can actually update the certificate authorities or add our own certificate authorities when we want. But the browser uses these certificate authorities to check if the SSL certificate given by a server actually belongs to the domain that we're making a request to. So to summarize, the easiest and in a sense the only way to guard ourselves against man-in-the-middle kind of breaches is to use HTTPS wherever possible, and to ensure end-to-end encrypted connections between our application on the client and our application on the server. So this is why browsers have started displaying a little green icon next to the HTTPS symbol. So whenever you go to a site that has HTTPS enabled, you'll see a little green icon, and if you click on that green icon, a drop down, and it will tell you what the details about this SSL certificate and what are the different subdomains that are covered under this SSL certificate. On the other hand, if you have an HTTPS connection to the website, but the SSL certificate has not been verified, or the verification has failed with the certificate authority, then you will get an error like this. So for example, in this case, the server might not actually be gmail.com, and some other server in the middle on our network is pretending to be gmail.com, and we have an HTTPS connection with that server, but that server is not gmail.com. Now let's move on to some best practices for API and web app development. Whenever we write an endpoint that is an API or a web page request, then we must ensure that the API has an authentication check and an authorization check. So we must check that if a user is claiming to be a particular ID, then the user actually has that ID. And we must check that whatever functionality is being requested for in the API or on the page is something that that particular user ID actually has the authorization to make a request to. We should also always sanitize all the inputs that users send. We should never trust the input that is sent by a user, the structure, the format, or the size of the data that is being sent by the user. We should also try to write as little code as possible to achieve the functionality that we want. We should use as many mature libraries that have been written by preferably the open source community as possible. For example, we should never implement our own hashing algorithm, which might have bugs and which might not be as secure as existing libraries. We should not store any credentials, tokens, or configuration data in our source code. For example, in our web app source code, we should not write the database username and password that our web app is using to connect to the database server. We should create the files that contain this configuration data directly on the server and not store them in our Git repository. If we need to share these credentials amongst other developers in our organization, we should use a service like LastPass to share these credentials. Once again, just like with front-end code, we should regularly update server-side software, the operating system, and other libraries that our source code depends on. When we are deploying our source code, then there are a few things that we need to make sure that we take care of. For example, our server might be outputting some logs. We might be printing out some logs as a program executes, primarily for a debugging purpose. We should remember never to print out logs that contain sensitive information. For example, in a login endpoint, we should not log the username and password that is being sent by the user, because it defeats the whole point of hashing, which was to store the sensitive data in a secure way. But in this case, logs will be stored that contain the raw username and password. So if anybody ever gets access to these logs, then that entire data is compromised. We should also try to separate the staging and production environments as much as possible so that we can test thoroughly, and during testing we can have a more lax attitude towards security, but during production we can take greater care of security so that debugging is easier on the testing environment, but the production environment is secure. When we are deploying source code or we are deploying binaries that are our server-side code on our machines, we should ensure that we are not deploying or executing any files that are not guaranteed to be from our own development team or are not guaranteed to be community libraries or operating system dependencies. We should use secure methods like SSH to manage our servers. For example, FTP is a popular method to upload files to a server. This is not secure. SFTP is a more secure version of FTP. Even when we use SSH, there is a method of setting up key-based access and not just using passwords to access, because if we use passwords to SSH into our remote servers, then we have to worry about sharing the password. When we need to access our database, we should ideally separate the administrative users of the database from users that have read-write permissions. So for example, the web app can use the read-write username and password for the database. If the web app is just reading data from the database, then we should create a separate read user and give the web app the read username and password to access the database. So this way we can ensure that even if the web app is compromised completely, they won't have more access than is strictly necessary when they talk to the database. We should also never execute raw SQL statements on the database if any part of that SQL statement depends on user input. And this leads to a kind of attacks called SQL injection attacks, which are the most common way of attacking databases and obtaining access to the database that allows hackers to download or delete content from the database. The key takeaways from this module are unfortunately each and every point in this module. It would be good if you spend time understanding why each point is a valid security point, and you can get into more detail about how they actually work. There are several useful resources on the internet that you should browse to understand these topics in more detail.